Hello, everyone. Thank you for joining our first LTM webinar. And we're super excited to collaborate today with GoodAI scientists, Olga, Martin, and Joseph, who are streaming live from Czech Republic. And also, the second speech will be from Luba Elliot, who is creative AI researcher, and we'll talk about flow with arts. And here we can see the agenda today. So the first talk will be, as I mentioned, by GoodAI. The title is Leave Your Mark on the Future General AI Challenge. So the talk will be half an hour, and then we have 15 minutes for Q&A. Then the second talk will be by Luba Elliot, which is creative applications of machine learning. And then again, we'll have Q&A at the end. So during this webinar, we'll have live chat on the right-hand side, where you can post your questions and the speakers will answer them after each session. If you're not watching this video live, then you can always leave your question in the comment section, and the speakers will get back to you shortly. So then, thank you very much, guys, for joining, and thank you for speakers. Finally, you can always tweet using our hashtag LTM, and we'll retweet all the questions and comments. And also at the bottom, you can see all the handles for GoodAI, GoodAI Challenge, and also the speakers. I'll pass it to GoodAI, who will be starting the first session.
Okay, so hello everyone. Great to meet you via this webinar. So my name is Olga. I'm Chief Operating Officer at GoodAI, and here on my left is Martin, who is one of our research scientists, and here is Joe on my right, who is also one of GoodAI's research scientists. And today we will talk a little bit about how you can take another step forward to general purpose artificial intelligence. So now let me just share our screen and put on the slides. Okay, so how can we accelerate towards general purpose artificial intelligence, and what can you do for this? So I see there's a little bit of a lag on the channel. Okay, now we're good. So the mission of GoodAI is to develop general artificial intelligence as fast as possible to help humanity and understand the universe. We, GoodAI, we are basically a research group, a privately funded company, which is sitting in the Czech Republic, in Prague, in the heart of Europe. And we are 20 people, 20 researchers and scientists. Our main goal is developing general purpose artificial intelligence. So we're doing basic research. We're not focusing on specific narrow AI applications at the moment, although our newly established sister company, which is called GoodAI Applied, is trying to apply our prototypes and ideas that we developed in our core team to some business applications. So here you can see also a picture of our CTO and also CEO, who founded the company in January 2014, and basically privately funded it. So we have this unique opportunity just to focus on our main research priorities. And why is our research priority general artificial intelligence? Well, we just believe that this is a kind of a tool, a kind of a technology which can help you leverage any other technology. And if we have general AI, then we can use it to optimize science, to optimize the research process, to optimize basically any field. And maybe this will be more a topic of Luba's talk. We will talk after about creativity. Maybe like even more creativity can come out of an AI which has these general capabilities. Some capabilities that current narrow AI solutions kind of lack, or have them just up to a certain extent, but they cannot compare to humans in all the aspects. So this is really like a very challenging frontier, and nobody has done it yet, unless we don't know about it. But I think we would know if somebody has already achieved general AI. So basically, the difference between general AI and narrow AI, as you might all know, is basically its capabilities. So general AI is something that we can compare to a human, something which has a very large repertoire of skills and which is able to learn new abilities without any limitations, and it can reuse its different skill set for solving completely unseen problems and come up with creative solutions to problems and so on. So this is a very complex problem, and basically in our team we put a very sharp focus on big picture thinking. And we have in this 20 people team, we have one roadmap that we follow, our R&D roadmap. And it basically encompasses different research principles that we all believe in. And then within the team, we have sub-teams which try different architectures and try a little bit different implementations of those common principles. So now I will just briefly explain what we mean by this roadmap to general AI and why do we think it's important. We just basically think that it's good to have a good plan when you want to achieve such a long-term goal. So our roadmap, our R&D roadmap has basically two parts. We think that an AI, a general AI or a human level kind of AI is basically some kind of AI which has a certain skill set which is useful for us humans and which is kind of similar to what we humans have as skill set. So we're kind of a benchmark ourselves. And we think that this set of skills in this AI, basically some of those skills can be programmed into the architecture, initial architecture, and some of the skills are or can be learned by the AI in the process of its education, its teaching by us, by human mentors. So our roadmap also has those two parts. On another slide, you can see at the right, at your right, you can see this long, tall, basically a roadmap, which has at the bottom some list of skills and abilities that we think we need to program into AI, some kind of a DNA of an AI, which will enable it to later acquire through gradual and guided learning all this rich and extremely diverse set of skills in the same manner as we humans possess. So basically, it can be compared to the way how humans are developed, how we become who we are. So first, the human is born with some certain skill set or some certain qualities, some capabilities, which are kind of encoded in our DNA. We just all have them from the beginning. And then it's very much dependent on what kind of things you learn as a baby, what kind of environment you are exposed to as a baby, then as an older person, and so on. So you're going through some kind of curriculum through your lifetime. And if you're lucky and you have a good curriculum, then you can develop very useful skills and also become, basically become a good person, right? So we also kind of believe in the same thing with our AI, that first we need to program some DNA of an AI and then put it through a proper curriculum, which will initially teach it very basic skills that we all teach human babies as well. And then when the time comes, we will also teach it those skills which will serve for developing a safe and beneficial AI. So this kind of AI safety and ethical values that everybody's talking about, how to basically ensure that AI has them, we believe that with the help of the right curriculum, this AI can acquire them, and we need to help the AI to acquire them. So it's going to be a lot of work on building those AI safety and ethical curricula. So this simple graph, if you can see it now already. Yeah, they do. Okay, sorry, because we see the lag on YouTube, so I wasn't sure. So there's a simple graph which just shows that we just think it's a matter of balance, that some of the skills that we believe this general purpose AI should possess have to be coded or programmed into AI, and some of the skills have to be learned through curricula. And then this is basically the question of finding the balance, what to put in the architecture, what we as designers of AI need to design, and what shall we teach it as mentors. And this way we're trying to find the shortest path towards general purpose AI. And also, as I was speaking about roadmaps, we recently started at GoodAI an independent AI roadmap institute, and its task is basically to focus on this big picture thinking, to focus on studying and comparing various roadmaps towards general AI, to start up and engage in conversations within the field, to try to map different approaches towards general purpose AI, and try to spot promising milestones that we need to tackle first and second and so on, and basically incentivize this big picture thinking and focus on longer term goal of general AI. And probably you have been waiting for something more specific. What are those skills and abilities that we believe are important to create, to code in the AI in order to develop general AI? And we believe that one of the most crucial DNA kind of abilities is, or properties, is what we call gradual learning. And different researchers call it different names. And basically, by gradual learning, we mean lifelong learning, learning how to learn, and essentially the ability to acquire skills on top of already learned skills without forgetting what you learned already, and the ability to reuse the skills that you learned already in order to solve new and unseen problems, and basically using your skill set in order to learn how to learn better. And this is essentially what humans do all the time, what children do all the time. And we believe that this is a very good foundation for starting from here to general AI. So of course, this is one of the milestones that we are now trying to tackle actively in our GoodAI research team, and also to scale up the search for this gradual learning AI algorithm or AI agent. We have launched the General AI Challenge to crowdsource basically the solutions for this problem. And this challenge is open for everyone to participate. And we decided to launch it as a long-term project, and we put $5 million in prize fund for various future milestones that we will have in this challenge, different rounds that will deal with different research milestones, not only AI programming kind of milestones, but also more, let's say, philosophical AI ethics and so on. And right now, we are almost midway through the first round of the General AI Challenge, although you are very welcome still to sign up and participate. And this one, with a prize fund of $50,000, is focusing on gradual learning. We also have a stellar advisory board and a very nice community support, which I will just quickly skip, and you can return to those slides later. And here's the timeline of the challenge. You can see that we started this first round focusing on gradual learning on February 15th. It will run till mid-August. And so you can still participate and actually try to play with those problems that we present in this round. And right now, for me, it's time to pass the word to Martin, who is one of the co-authors of the tasks that you can find in this first gradual learning round of our General AI Challenge. And so, Martin, probably over to you.
Thank you, Olga. I'll talk about the challenge and the environment. So first, what will you be doing? You will be interacting with ComAI environment that originated at Facebook, and we took it and modified it a little bit for the purpose of the challenge. And you will exchange bytes of information with the environment, and the environment will provide you some feedback. So initially, it looks like a plain reinforcement learning problem. We have a very nice specification document that shows you the tasks that you will be solving in the challenge, and you will notice that gradually the reinforcement learning problems become more complex, and it's no longer just reinforcement learning, but it's something richer, something where you need to also look at hints and act according to those hints. This picture that you're seeing, it shows the environment and agent and interface between them. And you see that it's a very simple interface. There's the agent provides a single action, which is a single byte, and the environment in turn provides a single byte of data and a reward, which is either -1, 0, or 1. We chose such a simple interface because we really wanted to concentrate on gradual learning and not to get lost or confused by noisy data on input. Maybe that would be the subject of future challenge rounds, but not this one. So what will you do? You probably guessed it already. Our main interest is in gradual learning. So you should build an agent that learns gradually, which means it acquires a skill and then uses that skill to acquire another more complex skill, and so on, like a human. When you're a baby, you don't know much, but you get a skill to crawl, then you get a skill to walk, then you get a skill to run and jump around, and so on. And you reuse previous knowledge to learn the new knowledge. How will we evaluate that you created some agent that has gradual learning capability? Well, first of all, we'll provide you a set of tasks. There are 40 tasks, public tasks, on which you can train your agent. The tasks, they have this gradual property. They start easy, simple, plain reinforcement learning, but gradually they get much, much harder, and they always reuse knowledge gained in the previous tasks. But mind, this is the public curriculum, and somebody might just decide, okay, I will solve the public tasks using hacking and brute force and whatever. This approach is not something we want because it's not general. We want you to create an algorithm that is so general that if you see an unknown hidden curriculum, you will still solve it. So that's our idea for evaluation. We will create another non-public curriculum and we will evaluate your agent's performance on that curriculum. Now you see some examples of tasks that appear in the public curriculum. As I was mentioning, if you go to our website, generalaichallenge.org, you can download the full specifications that list all the tasks, not just these 3 examples. So let's have a look. Task 5.3 on top. You see that there are 3 lines: input, output, reward. Recall the interface. So the environment produces a single character. This is 0, you see. Then the agent reacts somehow. So in this specific case, it reacts with a space. And then the environment produces a reward. In this visualization, we depict reward 0 by a space. Then the environment produces a dot, the agent produces a space, and the environment says this was a wrong answer, and it produces a minus. If you skip to the end of that line, 5.3, you will see that the environment produces a dot, the agent produces a 0, and that was the correct answer. By the way, in this task, it's interesting to try it yourself. So maybe if you go to the specification, look at the task and try to find out what's the problem, or even better, if you download the GoodAI environment, install it and run the task, then the environment will produce this input to you, those rewards, and you can try it out yourself if you're capable human enough to solve those tasks. We had humans who weren't able to solve these tasks. We had humans who were able to solve this task. Now let's go to the next task, task 9.2. You see that this task looks much more complex than the previous task, but there are some similarities. For instance, there's a period symbol, there's a semicolon symbol. They have their meaning, and the meaning is actually the same as in the previous task, although that might not be apparent to you at the first glance. And in this specific task, you're asked to insert spaces between characters of a word. So you're dealing with sequences and you're trying to process them in some clever way. The task 9.3 that we're not showing here is interesting from the gradual property view, because it asks you not to interleave the characters with spaces, but with some provided character. And doing that, you should recall, okay, last time I was interleaving with spaces, now I'm interleaving with some other character, so that's just an easy switch for me. In the last task, you see there's something even more advanced. You're asked to produce something that didn't even appear on the input. You have to think it up. And this kind of task leads to the most complex tasks that we will provide to your agent in the public training curriculum. Those most difficult tasks are the mini tasks that were published by Facebook as tasks for the future evaluation of AIs and tasks that are too hard to solve at the current moment. We think that those tasks are solvable actually using our curriculum. Here we have a video of the tasks, but I'm not sure if we have enough time.
Maybe we can skip it, or just quickly show in like a couple of seconds the way environment looks like. Yeah, so maybe somewhere midway through the video.
Okay, good idea. So here you see, previously you see some static examples. Now you see a dynamic example. This is what you will see if you download the GoodAI environment and try to interact with it as a human, which I recommend to you to do so. And you see the top line is input. Beneath it is the reaction from a human learner. And to the right is the cumulative reward. We have an improved version. So now if you download, you will not see the cumulative reward, but actually the history of rewards, those pluses and minuses that you saw in the example in the presentation. Maybe we can go to the next slide.
Get out of here. Okay.
And now I'll pass my word to my colleague, Joseph, who will share with you some of his experiences in tackling gradual learning in TensorFlow.
Thank you, Martin. So we have a small example to go along with this, which was written for ML Prague, but in the spirit of code reuse. You can look at it just now, or indeed at any other time. So it's on our GoodAI GitHub, so github.com GoodAI, and it's the ML Prague 2017 repository. So what I want to talk about is how to have an architecture which is able to gradually learn. Now, the problem with the gradual learning is we're not actually sure a priori how much information is going to be saved. So we've experimented with a couple of things in TensorFlow, and we have two solutions. The first one isn't really a solution though, but what you could do is you could make a guess and pre-allocate a number of experts, a number of networks, and switch between them with the conditional. Now, that tends to make a bit of a rat's nest of execution paths and tends to be a bit of a mess. So what we settled on, and indeed what's in the repository itself, is our ability to actually change the graph, the computation graph between session calls. So when you encounter a new problem, you're able to actually just train a new controller, as we call it, or train a new expert to solve that problem, and then allow subsequent experts to actually make use of that trained expert in order to solve new problems. So I'm not going to go super deeply into how it works, but we have the code in the repo, it's commented, and there's also a presentation which goes into this in more depth. But essentially what we have is we have a network which is able to perform actions. So in this case, we have a few intrinsic operations for like going forward and turning right. And in the model, there are two networks. There's a training network and an inference network. The difference is essentially in the batch size, and that's all. What we also do is we have an external session, which we use along with just the training network in order to train the model. Once it's trained, we save it. We appropriately scope, have variable scopes and name scopes in order to be able to find this stuff again. And we end up with a set of weights saved. So when it comes time to create a new model, we reuse the We reuse model 1, but we only take the inference. We only need the structure of what the inference is. And along with the intrinsic operations, we have a learned operation. And this learned operation encapsulates the inference part of the first model. It loads in the saved weights, and then model 2 is able to reuse the information, the skills used by model 1, learned by model 1, in training a new task. Now, the trick here is because these things are broken up by, well, you essentially have to take the graph offline in order to do this. But the challenge itself runs tasks smoothly together. So the trick is to be able to recognize when you need to take the graph offline and create a new expert for these. So the example that we have, and the link is on the slide there, is we have a gradual model which is able to learn multiplication by first learning addition. We have some intrinsic operations, and this model operates a stack machine. So we have things like push and pop. We also have increment and decrement. So what this does is first we give it this addition task, and after a few minutes it learns how to perform addition correctly. And then we save the weights, as we said, and move over to the multiplication model. So the multiplication model then is initialized. We give it the structure of the addition model and the weights, and it initializes those. And because the multiplication model is able to just use the information learned by the addition model as a new instruction, we're able to very quickly learn how to do multiplication as opposed to not using learned information already. So that code there is available for you. You can use it. You can play around with it. You should actually also be able to reuse the multiplication to perform exponentiation. And we're, well, our emails are in the slides, which are also linked there. And you can talk to us if you have any ideas. And yeah, so that's a very short introduction to how we're dealing with the gradual learning in TensorFlow. I'll pass you back to Olga now.
Yeah. So just to get back to the challenge, basically, you can see that we ourselves are trying to tackle gradual learning problem in our team, and you can also be part of this effort by signing up for the General AI Challenge, downloading the set of tasks that Martin was presenting in the challenge, and use them as some kind of a benchmark for you. And you can, of course, also go and download the example architecture developed in our team that Joe was talking about, and you know, maybe you will come up with even better ideas and decide to share them with the rest of the world, which would be amazing. You can see that there's quite a lot of people who already kind of became interested in all this in the challenge and joined the challenge. So we're planning more. We're planning to also introduce various problems and more difficult, let's say, more difficult tests for gradual learning agents. For instance, as Martin was mentioning, in more complex environments, and so on. So these will be topics of the future rounds of our General AI Challenge, as well as I mentioned. Various topics related to AI safety, AI road mapping, futuristic road mapping, different risk mitigation strategies for creating a better future with general AI. And of course, we're very welcoming all of your suggestions. And now I guess it's going to be time for questions. If you want to post any questions right now in the live chat, please do. Otherwise, I will also put there our emails, as Joe was mentioning, so you can also write to us directly and chat about anything you'd like to discuss in more detail. And yeah, maybe we can then pass the word over to Luba.
Okay, great. So now I'm going to talk a little bit about how you can use AI and machine learning in the creative industries. So I'm just going to share my screen. Okay, so apologies for this. I think, and I hope, we're all now sorted, so we can go back to the presentation. Yeah, so as I mentioned, I just wanted to give you a little bit of information about my background. So I come at it more from an artistic perspective, shall we say. So what I do at the moment is I run the Creative AI Meetup group in London. And this is a series of monthly events showcasing new technologies that you can use in the creative industries, or works from people who have used these technologies to create fun music songs, or beautiful visuals. And in addition to that, I've also played around with some recurrent neural networks myself to create a performance, which I will mention a little bit later. And I also sometimes write and review art exhibitions to make sure that I still have a perspective on the way the contemporary art community looks at this topic. And some of my time is also spent at looking at how artists and creatives are using AI both to create work and also to implement in their businesses. And my previous background was working partly in venture capital and then partly in art and technology startups. So looking at how you can bring new technologies into the art world. And so here is a little slide showing some information about my meetup. So there's a link at the bottom. If you're based in London, you can join some of our events. They're normally held on a monthly basis. And these are the types of speakers we've had at the event. So we've focused quite a bit on making sure that the creatives and the general public are aware of the algorithms you can use to generate music, such as WaveNet, or some of the ways you can use computers to collate images for aesthetics, which is Miriam Reddy's research. So these are the types of things we've looked at the meetup. And so now I'm going to talk a little bit about kind of what I mean by this creative AI term. And so this is a term that is now probably considered a rebranding of computational creativity, which in itself is a combination of disciplines, which includes artificial intelligence, cognitive psychology, philosophy, and the arts. And what this discipline aims to do is to model, simulate, and replicate creativity using a computer. So some of the work Olga and the General AI Challenge are doing are, I guess, very much in line with some of the goals of computational creativity field, who ultimately aim to emulate and enhance human creativity. And why would you want to use AI in the creative disciplines? So there are a few reasons why you would look at it. So one of these is democratization. So nowadays, you don't have to be a trained classical painter if you want to create an image that looks like a Van Gogh. You can use the Prisma app and style transfer algorithms to quickly change your photo into a work of art. And then secondly, optimization is also a reason. So what you can do with all the data you have about a particular set of individuals, you can create artworks or songs that are based on an individual's data set. So that will, of course, enable you to create a lot of artworks at scale. And then there's the more possibilities side. So if you start playing around with all these models, maybe they will come up with new ideas that you as a human will have never thought about, because maybe they weren't socially acceptable, or maybe you just never came up with them. And so this way machines enable us to be more creative in different ways and to create new art forms that machines and humans can enjoy. So I'm going to go a little bit to the beginning of the hype. So the field of computational creativity has quite a long history, starting from the 60s with some of the work done in Bell Labs. But recently, there's been a lot of interest in the field as AI started to get into the mainstream press. And I think one of the points when it started to get really popular was around almost 2 years ago. So in July 2015, when the Google Brain team released a convolutional neural network called, I guess, Inception or Deep Dream that enables you to find or enhance patterns in images. So I'm sure you're all familiar with this. And on the left side, you can see a typical image. So it's very kind of trippy, very multicolored aesthetic. And on the right hand, you can see an artist's rendition. So Mema Akhten is an artist from Goldsmiths who has completed a residency in the Artist and Machine Intelligence Group in Seattle, I think. And so he used Deep Dream on an aero kind of visual of I think one of the government headquarters, and run the Deep Dream algorithm on it in black and white, and then you can kind of see the image he got. And to me, this is interesting, probably less in terms of aesthetics than it is in terms of the fact that this sold for £8,000 in February 2016. So you can see that there are some collectors who are also open to supporting these types of artists. And then there was a wave of interest with the style transfer algorithm from the Bethke lab at the Max Planck Institute in Germany. So I'm sure you're all familiar with this paper as well, called The Neural Algorithm of Artistic Style, that has recently had a few updates, and there are also various apps coming out, such as the Deep Art website, and some others which I will show in a minute. Actually, yeah, which I can show here. So there was the Prisma app, which came out last year, and it had 7.5 million downloads in just the first week. It was probably the most popular app over the summer, and yeah, what made it so popular was that by that time, the algorithm had a much faster processing speed than its competitors. And apart from that, another interesting occasion of neural style transfer is the fact that Kristen Stewart, so one of the Hollywood actresses, I think she's famous from Twilight. So she actually co-authored a paper on neural style transfer in her short film about Come Swim. So to this paper, she brings her perspective of an actor and a film director, and it was in combination with some researchers from Adobe and Starlight Studios. But this is, of course, is quite interesting because it's you can see, so Hollywood, a large entertainment industry, is paying attention to the latest techniques to incorporate them into the work. So yeah, on the one hand, you do have Hollywood that is, I guess, looking at this technique. And then on the other hand, you do have the contemporary art world that sometimes kind of questions these techniques and their applications. So at the end of last year, I went to the NIPS conference on machine learning, and there was a workshop on constructive machine learning, where there was a presenter from Goldsmiths University called Simon Colton, who talked about his views on style transfer from, let's say, a perspective of somebody who is well versed in the arts and computational creativity, and he was quite negative towards it. So he felt that many of the works created with style transfer were mainly pastiches. So they were a copy of a particular image, but they kind of missed the essence of it. And then he also felt that this type of approach looked at art as a product and not a process. And nowadays, a lot of the contemporary art trends are almost as much about the process as they are about the product. So of course, if you apply some of these techniques without kind of thinking too much about what exactly you're looking to do beyond achieving a pretty image at the end, then this is something that will be missing to the art world. And then, of course, it could also be considered, stealing. So you're taking something, so you're using a style from an artist that has, who has worked quite a while to develop it, and you are finding and you're using technical tools to make that happen in your work quite quickly. So I think this is just an interesting illustration of another perspective on style transfer, and perhaps some of the other tools that are currently being used by the technology community for experimentation, and then also to create artwork. And so now I'm going to talk a little bit about some of the projects that have used machine learning in the creative industries. So I want to mention first the Beyond the Fence musical, which premiered in the West End in London in February 2016. And there, the computer was involved in both the plot as well as the music and the lyrics. So here you can say that the team went a little bit crazy. And this is an image of what the musical was like. And in terms of the plot, it was set in the 1980s, and it told the story of women protesters at Greenham Common. And there was also a love story element, and a mother and child story. So in terms of the general plot characteristics, so the time period in the 1980s, the element of protest, and the romantic plot. So these elements were all figured out based on an analysis of 1,600 musicals, and then it was the human curation that decided to pick that it should be September 1982, and that it should have a US military person and this specific love story. So it was a combination of humans and algorithms there. And in terms of its reception, many people thought that it was more of an experiment, and actually the fact that in terms of the plot, it was trained on the previous musicals, the final results ended up having the same problems as a typical musical, and it seemed somewhat dated in style. So this is this is quite an interesting, I guess, critique of the technology, right? So ultimately, the end result that was, or the end options that were that were generated using that particular technique were not new enough to please the critics, because it was on all these previous data sets. And yeah, you can see it was mainly 2 to 3 star reviews from various places. And then in May last year, Terry Broad, a master's student at Goldsmiths, did a project called Auto-Encoding Blade Runner for his master's dissertation. And so what Terry did is he used a variational autoencoder to reconstruct the Blade Runner film frame by frame. And yeah, you can see there were some issues in terms of copyright. So the end result of his reconstruction was so close to the original that that YouTube had to take it offline for a while because of these disputes. Let me see if the video will work. Yes, it's just loading. I'm gonna show you a little bit of it. So on the left, it's the original, and on the right is the reconstruction. So you can see, I guess the quality is quite variable, but ultimately it was an interesting experiment in figuring out how a machine sees a film and what it remembers, and what it remembers from what it has seen. Okay. And then I'm just going to mention another project that is about Blade Runner from Ben Bogart. So this is an artist based in Canada who actually also came up with the idea of using statistical techniques and computer vision algorithms to reconstruct a film. And it turned out to be also Blade Runner. And I don't think the video of his work is easily available online, or at least I wasn't able to embed it. But you can see from an image that the aesthetic of it is quite different. And if we continue to look at film, I wanted to mention the work of Lawrence Leck called Geomancer. And this is a film set in Singapore in 2065 about an AI that wants to become an artist, and it's actually currently still on view at Jerwood Space in Southwark until the 14th of May. And so this is a film about an AI that really wants to become an artist, and it's around 50 minutes long. It starts with the AlphaGo victory with the Lee Sedol match, kind of a fictionalized version of that, and then it progresses to look at this AI and its perspectives on Singapore society in 2065. And it's particularly interesting because it also uses the variational autoencoder from Terry Broad to reconstruct the first 40 or so minutes of the film. And so if you want to see that, you will have to go to the Jowett space. And if we stick with film but move away from the visual side, there have also been a variety of efforts to look at how you can generate text, and in this case, the script of a film. So this was done in 2016 by Ross Goodwin and Oscar Sharp as a short science fiction film as part of a 48-hour filmmaking challenge. So this film has been entirely written by LSTM, Recurrent Neural Network, trained on human screenplays that are found online. So it's mostly movies from the 1980s and 1990s. And yeah, so in terms of this film, the critical reception again found it somewhat experimental in nature. And if you do watch it, you'll be able to see that it's not often coherent in places. So a character might say a line and then the reply of the other character might not make so much sense. But you know, it's a great example of also the artistic talent the curators and the artists bring to working with these techniques, because ultimately even the set directions were generated by this torch RNN, and the artists and the actors, you know, they really had to think about how you really convey that. So it's if you haven't seen it, it makes for some fun watching. And the guys behind the project actually recently released another film with David Hasselhoff that just premiered yesterday, and it's about a conflict of human screenwriters and AI screenwriters. So that's also worth a watch. And this is about my work called Play the Turing Test. So I did a series of performances that were based on two texts. So one was written by Torch RNN and the other one by a human. And then I found volunteers who I put in groups to act out these texts, either as robots or as humans, according to their interpretation. So ultimately, there were 4 variations of each performance. There were some that were acting the AI generated text as humans. There were others who were doing it as robots, and then the other way around with the human text. And in terms of writing the text, I trained the Torch RNN implementation on 1 million characters of George Bernard Shaw plays. And I'm somebody who's still learning about the field of machine learning, so I figured, you know, the results I got were probably not the most impressive. So therefore, it would only be fair if I engage a human who is also learning about the field and who is not a professional writer. So I asked somebody who writes as a hobby, and in her day job, she's a business intelligence manager. And yeah, so these are some images of the performances which I did in Berlin, Sheffield, and in London. And ultimately, the main conclusion from these performances was that the verdict depended a lot on the performance and what they brought with them. So there were some performers that decided to look at AI more from a mechanical android standpoint, and yet there were others that thought about the robotic Siri voice. So there was quite a range of performances, and this meant that often there would not be a clear consensus on who had which combination, which made that a little fun. And in terms of contemporary art, there were some efforts by the Tate called the IK Prize. And this is a prize that the Tate has been doing over the past few years. It's about using digital innovation methods to make the art collection of the Tate more accessible. And last year it was focused on AI. So the winning project is called Recognition by Fabrica, and it compares up to the minute photojournalism with British art from the Tate collection. And you can see in this image at the bottom, you have on the one side, there are some ladies putting makeup on, and on the other side, it's matched with a historical painting. So this is just some ideas. And in terms of how this applied, I guess, AI, technically, you can see that it focused on object and facial recognition, and then also looked at composition and context analysis. So in terms of this work, it was actually a collaboration between the Studio Fabrica and the technical company Jolly Brain, who used Deep Detect and then a variety of Microsoft Cognition Services APIs to make this project happen. Yes, this is another image. And looking at some more recent projects in the contemporary art field, there are some by the artist Constant Dullard, who is a net artist from the early 2000s, who collaborated with Adam Harvey, who brought his technology perspective to this, to create ImageNet.xyz project. And so this project was about building a data set called Euronet of stereotypically European images and concepts. So you can see here there's a lot of cheese, there's goulash, halloumi. So there are a lot of foods that carry a lot of cultural significance in Europe. And what the creators wanted to do with this project is to really showcase some of the bias that are present in some data sets, and kind of look at the data sets from a more European rather than US-centric perspective. And in terms of what they used, so Adam Harvey, the technologist, used a combination of methods with plug-and-play generative networks in Caffe, and then image search tools. And yeah, so you saw the images there. And then I also wanted to show you some of the latest works that were made with GANs. So this is an image from Ross Goodwin, who is one of the authors of some of the films I showed you earlier. And here he trained a GAN on a set of the Museum of Modern Art thumbnails. and you can see the kind of images he got after, I guess, 16 hours of training. So these could very easily actually pass as paintings. And then recently there was this Zero Likes Twitter bot, which is a DC GAN trained on 100,000 Instagram posts that received 0 likes. So it's about kind of looking at the underappreciated and looking how machines can respond to the abstract and the human qualities. Yeah, so this will be it from me, and this is my email if you have any questions, and there's also my Twitter handle. And yes, please do come along to my meetup. It'll be great to see you. Or if you have any questions or interests, I'm very happy to put you also in touch with some of the artists.
Great. Thank you very much, Luba, and thank you, GoodAI. Were wonderful sessions. And for the attendees, if you have any questions, please leave them in the comment section, and the speakers will be happy to get back to you later. I hope you enjoyed the webinar, and please leave any comments on the meetup as well. And we're looking forward to collaborate again with GoodAI and Luba as well. So thank you very much for joining.
Thank you very much, everyone. It was really great to meet up like that. Luba, your talk was also fantastic. Thank you for sharing everything.
Yeah. Thanks so much for listening. Thank you.
Thank you. Bye.
Bye.
Thank you. Bye.